Alright, on the last video I mentioned how important a vacuum tube manual is, and it's more than just looking up the specifications of a tube. It also gives you circuits of things you can build, should you choose to do so. It also gives you theory of how a vacuum tube works. Now, there are a lot of videos on YouTube, so I'm not going to be going into too much of that because I am not that good at these things. But however, for you newbies out there, or those of you who are just starting to work with vacuum tubes, let's go over a few things that you will see in a tube manual. Basically, the parts of a vacuum tube, starting out with the envelope. We're not going into any certain order here. The base, which is glass, and the metal pins that come through it. There are a few good videos on YouTube as to the actual building of vacuum tubes, that you may want to do some searches and find those. So, you have your getter, which removes the last of the air molecules out of the tube after it's been evacuated. Your mica separators that keeps the elements separated, like your grids and stuff. You got your plate here. You've got your grid assembly here, and there's some more grids over here. Your cathode sleeve, and your heater, or filament. You remember I was discussing about directly heated cathodes and indirectly heated cathodes. The book goes in thorough detail of how this works, so I'm not going to be trying to read this thing. I'm a slow reader because of my eyesight. So if you get yourself a tube manual, and especially the RCAs, but I'm sure the other tube manuals will also have this information. But your RCA tube manuals in the beginning of the book will usually give you quite a few details about how a vacuum tube is constructed, how it works, and so on and so forth. And I'm not going to go into every single detail about this. Your directly heated cathode is a cathode coating on top of the filament wires, which are nichrome wire, the same type of wire that is in your electric light bulb, incandescent electric light bulb, okay? And it's coated with a cathode material which, when heated, emits electrons, okay? Your indirectly heated cathode is a sleeve that is placed over the filament, which is this part, but without a coating, because the cathode coating is on the outside of the sleeve, and the heating element or filament is inserted up inside, and when heated, it heats the sleeve, in turn heats the cathode material and emits electrons. All this is discussed quite thoroughly in the tube manual, so I don't need to go into that. You get yourself a tube manual and do a lot of reading. I have done much reading years ago when I had good eyesight. Sometimes it's easier to read these things online. I know it is for me now. Your vacuum tube has many functions. Your basic circuit, basic diode circuit, this being your filament supply battery, in this case it's a battery, a symbol for battery, and your B plus through a resistor, monitoring your plate current with a meter here. A diode will only conduct in one direction. So a vacuum tube makes a very good diode. Higher voltage drop between the cathode and the plate compared to a solid state diode like a 1N4007 or whatever. Again, you'll find all these circuits in your tube manual. Here is your basic triode circuit. A triode is a 3-element tube. You do not count the filament. Your elements in a 3-element tube is the cathode, the grid, and the plate. Your grid serves as a gate. When it is positively charged, more electrons will flow from the cathode to the plate. When it is negatively charged, depending on the negative charge, less electrons are flowing from the cathode to the plate. It can be so highly negative that all electrons can be stopped from leaving the cathode if it is negatively charged too much. So when you control, that is why they call it a control grid, when you control the grid, you are limiting the current flow from the cathode to the plate. Another thing too, in an amplifier, whatever voltage appears on the grid, a higher voltage alternating current, that is, will appear on the plate and will occur at the plate load resistor. Your B plus is fed through that plate load resistor to your plate. Your signal is taken off of the plate to a coupling capacitor, unless your amplifier is direct coupled. This is a basic circuit. All theory and stuff like that you'll get from your tube manual. I am not a teacher. I am a tinkerer. I'm trying to help the newbies out. A beam power tube, like a 6L6 for instance. You have your plate and you have some directing plates that will direct the electrons to the plate rather than to be scattered all over. That is why they call them a beam power tube. Like I say, your 6L6s, for instance, is a beam powered tube. You will have, and I cannot read that, I am sorry, have to excuse my eyes. You'll have a cathode, you'll have a grid, you'll have a plate, beam directed plates, and you'll have your electrons. This simulates the electrons leaving the cathode, going through the grid, going to the screen grid. And when there is a suppressor grid in certain tubes, the suppressor grid prevents electrons from bouncing off the plate and back to your control grid or even your cathode. You get some stray electrons. That is why they call it a suppressor grid. Some tubes have that. So again, this is all discussed in the tube manual. So it's a very valuable book. Vacuum tube manual is not only useful for radio tubes, but also goes into television picture tubes and so forth, which in this day and age is not really useful anymore. However, I did quite a bit of television work back in the good old days. Black and white TVs, dabbled a little bit in color, but not all that knowledgeable anything. But basically, as you can see, it's quite detailed. You can get a lot of information out of a vacuum tube manual, whatever you want to call it. And again, getting very briefly here with this, your electron flow from the cathode, again, the same thing as a basic vacuum tube, through your control grid or grid 1, and it goes to accelerator grids and a focus grid. Now, some of your real old televisions would have a focus magnet, and some of them would even have a focus coil on the neck, okay? And then it is accelerated, and on the aqueduct coating on the tube is where your high voltage button would be, and that is where the electrons are being accelerated toward and slamming into your phosphor screen, which in turn makes it glow as the electrons are hitting the phosphor on the face of the picture tube. What accelerates this is your aqueduct coating or high voltage coating, that's a coating on the inside of the CRT or cathode ray tube. And that high voltage on a black and white TV could be 10,000 to 15,000 volts, and on a color TV tube could be as high as 25 to 27,000 volts, and usually regulated with a shunt regulator 6BK4 tube. We're not going to get into that. There's plenty of articles on YouTube about that. So I'm just showing you this because this is what a tube manual can do for you. It's a very valuable book. In addition, there are a lot of circuits that you can build, things you can build, or if you're working on a, well, here is a preamplifier for a ceramic phonograph pickup. And this is a preamp circuit, which you can build if you're working on these things. Your ceramic cartridges have a higher output than a magnetic cartridge. Fidelity-wise, your magnetics are there. That's what I used in my AR turntable. And you also have some basic phonograph amplifier, simple two-tube amplifiers. So there are a lot of circuits, and they even give you the parts and stuff like that. Nowadays, nobody's really probably building that stuff. I certainly am not. But I have built a few things in my years, but not that much. I usually like to work on something that's already been built. High fidelity amplifiers, FM stereo multiplex adapter. I'll tell you the honest truth, I was not too good at that stuff. I could not quite understand it. I worked on a lot of FM radios, and I was lucky I never had to align one and figure out how to do it. But I probably could have if I had to, but The stuff I've worked on it usually worked pretty good, and it usually was in the power supply and so forth. So again, I'm not really all that knowledgeable on it, so I don't feel that I'm qualified for this stuff. But I think I can give some information, basic stuff, to help most of you out that have never done this before. Even FM tuners. So there's a lot in Citizens Band receiver. Quite a schematic. So there is a lot. Now, here's your shoulder type tubes. Your dimensions of them, your outlines of the different types of tubes, your metal tubes, your metal tube with a grid cap on it, your long metal tubes like the metal 6L6s, tube basing diagrams, more tube base diagrams. Now you heard me mention 6BQ6, which is a horizontal output tube. It's a beam power tube, but it is primarily a tube used for the horizontal output of a black and white television set. It is not heavy enough to be used in color. These tubes have a plate top cap. Okay, there's the tube basing of it. It contains all the grids, your suppressor, your screen, your control grid. And the reason I'm mentioning this particular tube is to try to clarify the grid cap or plate cap, whichever the tube is that you're clipping it to, on a tube tester. The tube tester needs that plate cap or grid cap in order to complete the emission test of the tube. So I have done many of these black and white sets that use 6BQ6s, 6BG6, which is essentially the same thing. I believe it's a little heavier duty. I remember back in 1959 having to pay $6 for a 6BQ6, and I said, wow, that's a lot of money. How am I going to replace my 6BQ6? In one of the televisions I was working on, I don't remember what it was, but I don't know, I acquired one eventually. And here is your 6BG6 that was used in the GE locomotive set I once had. We call it a locomotive because basically it looked like a locomotive. It was a Bakelite cabinet. And it was one of the first televisions I worked on. I couldn't get that thing fixed, but don't forget this was 1959. I was just starting out. So, you know, when you start out, you have to learn the hard way, and unfortunately a lot of sets got junked because I could not get the damn things working. Until when I took my TV and radio course out in 1962. Before that, I was just tinkering. Well, I'm still tinkering to this day. And of course, your 6X5 full-wave rectifier, which we discussed before. And these are noted for shorting out at times due to a heater to cathode short, because sometimes there's a breakdown between the heater, which is the filament, and the cathode sleeve, because these are indirectly heated cathodes, and your filament winding on your power transformer that supplies the 6.3 volts for the filament is insulated very well in the transformer. So if you've got 450 volts on the cathode of your 6X5 with reference to the chassis, which you would have, because your input filter goes there, usually through a resistor, but not always. In that case, if there's a short between the heater and the cathode, usually your transformer will not be affected if it's insulated good internally, but it can happen. However, having a short there, you're going to have direct B plus on your filament, and you could have a problem with your high voltage. Especially if there's more than one 6X5 on the same filament, and usually this is not the case, but sometimes there will be other tubes on the filament, but that's very rare because usually in a parallel circuit, which is what we're talking about here, this would not be used in a series string set. Your filament on most of the tubes, one side is grounded to chassis, and so is one side of the filament winding off the transformer. One side of the filament is grounded, and the other side goes to all the high sides of the filament, and the other side on the tube itself is grounded. But usually on a 6X5, it has a dedicated winding, so usually not a problem, but these have been known to short heater to cathode and can cause problems, so it's not a very good tube to use for that reason. Now, this really won't interest a lot of you and no longer interests me. When I worked at Aikens, we sold a lot of these tubes. 6BK4 lead glass for X-ray. It's a shunt regulator tube, sharp cutoff beam triode. The plate of this tube goes directly to the second anode button of a CRT, color CRT, which could have anywhere between 25,000 and 30,000 volts on the plate. And it is controlled by the grid, and it's a regulator so that the high voltage don't go too high. And these fail quite a bit. And we've sold a lot of them. At the time I was working in 1978 in Aikens Electronics, sold a lot of them. They would go for a dealer cost of $6 a piece back then. And they're very high voltage ratings on them. I'm looking at the specs here, but I really can't see too good, as you well know. But this really don't interest you, but it gives you an example of the different types of tubes that you will run into by getting a vacuum tube manual. So with that in mind, you can really appreciate the value of a tube manual. Now, there are manuals like your ARRL handbook for ham radio. I don't have one. I did years ago. And there are industrial tube manuals, which will have the industrial tubes if you're into that. And there's also ham radio tubes, which I don't believe are covered in here. And before we close out this video, which is going to take me hours again to render, eBay has a lot of books. This is a radio handbook. I don't use it very much, but if you want to learn about the theory of radio and how it works and everything else, it's a very good book to have. And it tells you a lot of things. Again, a very good source of information. I'd rather have a book than trying to look on the computer and struggling through the pages of a PDF file, when it's 100 times quicker to look at a book like this. Here's a 1947 tube manual. It's in the package I got from eBay that I've referred to at times. Here is another manual. So when I need to look up something really old, because I didn't show you these on video, I refer to them. Coin Electronics. This is not one of the books that I got when I took my course. This is one that I got many years ago, and I don't remember where. I even got a basic electricity book, which was a carryover from my old shop. And these, I'm not sure where I got them from. Then I got some transistor manuals. All these here I bought on eBay. Everything from here over, and these here. Okay, so it's very important. As you can see, you should have some sort of a small inventory of the tube manuals, and of course if you're into transistors, those also. It's a lot better to look them up in a book, at least for me, and I think a lot of you agree on that, than it is to look on their PDF file and take hours trying to find a certain tube or a certain page in the book. So it's very important to have paper material that you can refer to when you're working on something. I hope this video was of some help to you out there. Again, I am no teacher, but maybe to you newbies out there, somebody that's just starting out, fine. There are a lot better videos out there on tube theory and so forth. This video is primarily just to show you how valuable a tube manual is and can be very helpful to you. Thank you for watching. I appreciate all the kind comments I got on the last one.